What's up, spaceflight enthusiasts and scale modelers? Welcome to a model kit discussion. It's your host, Ray. In today's video, I'm going to be talking about my 1 to 200 scale replica of the Space Shuttle Columbia. This is a plastic building kit that I built in March of 2023. It took me about a week to build. It was pretty fun. And in this video, I'd like to talk about why I chose to build it, and more importantly, why I chose to build it in the configuration in which I chose to build it. I'm going to be completely honest here. This is just an excuse for me to show off and talk about something that I'm very proud of. So with that being said, let's carry on. This video should be pretty interesting. It won't follow the same structured pattern that my other videos follow, and it should be pretty casual. So sit back, relax, and let's talk about space shuttles and history. Before I start talking about the building process, I'm going to give you a quick 360 of the model so you can get a good look around it. So for this shuttle, I built the Space Shuttle Columbia in the configuration it was in for mission STS-107. Mission STS-107 was the final flight of the Space Shuttle Columbia, and it was also, unfortunately, the second disaster in the Space Shuttle program, hence why I chose to build it. More information about the disaster itself and the effects it caused will follow later in the video, so stay tuned for that. So overall, the construction of the orbiter was pretty simple and straightforward. There is a decent amount of parts that are needed to fully construct the orbiter, and they fit together pretty well. Hasegawa has some pretty high quality kits. That is the manufacturer of this kit, by the way. I'm sorry I didn't specify this. The challenges that I had were due to the modifications I wanted to make in order to successfully replicate some of the details that were exclusive to the Space Shuttle Columbia. During the construction of the orbiter is when I met my initial challenges for modifications, and both of them exist on the vertical stabilizer. The first one was the addition of the SILTS pod, or the Shuttle Infrared Lee-Side Temperature Sensing Pod. It's this little pod right up here at the top of the vertical stabilizer. The kit is not manufactured to allow for the inclusion of this pod, so I had to get creative and make one myself. The procedure I used was I cut off the designated part of the vertical stabilizer, and I replaced the gap with a spare plastic part that I had, which I had sanded down and modified to resemble the shape of the SILTS pod. And after a bit more sanding, tinkering, and filling, and cutting, I was able to successfully replicate the shape of the SILTS pod. After that, it was pretty straightforward from there. However, another thing that the vertical stabilizer had that this kit did not replicate due to its age was the drag chute compartment at the bottom of the vertical stabilizer. This compartment, as its name implies, held the parachute that helped slow down the space shuttle during the landing procedure. I had to cut out the correct part from the vertical stabilizer, and I also had to add some styrene plastic at the bottom here. And you can definitely see where I made the cuts and the addition of the styrene plastic, since there's a very well-defined line on this left side of the vertical stabilizer, and also on the right side there too. It's even more defined on the right side. So I didn't really do the best job of adding this, but in my defense, it was very hard to do. To my knowledge, the first time anyone's ever done this specific shuttle and this specific modification of 1 to 200 scale, so give me some credit there. At least it's done, and I think I did a pretty good job with it, so I'm happy. My struggles were far from over, though. It was during the fine detailing process and the application of decals where I started to encounter my second challenge. By this time in its flight history, Columbia was an old shuttle. After all, it was the first space shuttle that did fly in space, so it was starting to show her age, both in terms of functionality and external appearance. The first concern that I had was weathering of the fuselage in order to show both the weathering and the thermal protection system differences. The crew cabin was surrounded by thermal protection tiles, which was unique to Columbia. By 2003, or the final flight of the shuttle Columbia, the rest of the fleet had been fitted with thermal protection blankets as opposed to tiles on the white parts of the fuselage. However, Columbia retained her tiles on the crew cabin. However, the fuselage were covered in the blankets that I mentioned earlier. And there was a difference in color, and I had to replicate this difference by using a light brown paint wash on the fuselage, which you can see here, and then washed out black paint on the crew cabin. You can see the defined line here. Obviously, I wasn't going to carve out the tiles and the blankets, so this was the next best option I could do. It's a bit more visible on the right side of the spacecraft. You can see how this side has some brown on it, while this side does not. Another challenge that I had was the application of the decal for the window frames. These window frames, yes, it is a decal, and I'm just going to say this right now, you are not putting it on there successfully without decal softener. Decal softener definitely saved my life here. But the challenge I had was achieving successful alignment with the cockpit windows. And after a bit of tinkering and this decal being stubborn, as you can see, I finally got it on there, and I aligned it almost exactly with the outlines of the frames on the glass part there, which was pretty satisfying. The last challenge I had up here was painting the thermal protection system around the RCS thrusters, and this was due to the fact that the parts were very small, but I did have the advantage of having those sections outlined, so painting them wasn't as hard, it was just very time consuming. One more thing I'd like to add, painting the RCC here on the nose was also a challenge, mostly because masking was very weird, but since my airbrush doesn't spew out paint at very high pressure, I was allowed a bit more leeway in terms of what I could do with the airbrush and not get paint on the black thermal protection system, and it worked first try, so I can't really complain. And I'm very happy with the way it turned out, and I think it looks pretty good. The next set of small detail challenges comes with the payload bay and the fuselage. So you can see the payload bay hinges are not exactly aligned, and this is partially due to the door not exactly aligning with the fuselage, but you can also see the squares back here on the rear half of the payload bay hinges are not exactly aligned, and that's actually supposed to be like that. However, with this kit, the decals that are included for the payload bay hinges are one piece. So if you want to move the payload bay, you'd have to separate them and split them in half in order to do that. And that was rather unrealistic, so I just separated the decals in half, and I put the decals on the stationary part of the payload bay, which is the fuselage, and I hand-painted the movable part of the payload bay. That way I could open the payload bay and expose the interior. And that was kind of a silly decision on my end, because I don't have any details in here. I have the payload bay empty right now, and don't mind the photobomb of my math textbook there. There we go. In here, for mission STS-107, the payload bay had the Space Hab Research Double Module and the Extended Duration Palette. I'm not sure exactly what the acronym is, but yeah, this held extra oxygen, and the Space Hab Double Module had a ton of scientific research experiments that the astronauts were going to, well, that they did end up performing in orbit. The next absolute disaster I had was with these little vents. This kit includes a decal for everything at this rate, and the vents here were no exception. The kit allows for the application of small rectangular decals into these vents. However, these decals had a clear outline around them, which didn't allow me to fit them into the holes for the vents, so I painted them manually. As you can see, though, there's a bit of black paint surrounding them, or a bit of stain of black paint, and that's because I accidentally washed over it with water thinking it was going to clean it, but instead the water got inside the vent and ended up making the paint a lot thinner than it needed to be, and it was a whole fiasco that I ended up clearing, but it was very hard to deal with. I had a lot of issues on the right side of the spacecraft as well, mostly due to my incompetence and impatience and clumsiness. The first thing was with the black chines here. These actually made detailing the wing a little bit easier since I didn't have to detail as much of the thermal protection system. However, during one of the applications of white paint, part of this straight up ripped off and exposed the plastic skin, so I had to repaint that a few times, which that was really a minor inconvenience, but it still sucks that it happened. Another thing that I had an issue with was the United States titles here. So this kit had two sets of United States titles, one with the NASA logo and one without the NASA logo. I used the ones without the NASA logo because they had the correct orientation of the American flag on the right side of the spacecraft. The original ones had the American flag in the wrong position to what it really was on the space shuttle. So I simply had to chop off the NASA logos and pair it with the decals without the NASA logos in order to get the right orientation there. The last bit of my challenges were also centered in the back of the spacecraft here. The application of the decals for the ohms pods shouldn't have been that hard in theory, right? Well, since my clumsy self, I was going to use a different word that I probably would get demonetized for, not that I'm monetizing anyway, ended up using water-based paint to paint this black section of thermal protection system on the ohms pod. These are water slide decals, so you can imagine what happened when water came into contact with the paint. The paint completely came off. It was a whole disaster that I had to fix. I ended up applying the correct paint and later applying these decals for thermal protection system, and it came out okay, so I can't really complain too much. The last challenge I had back here with decal application was the application of the Elevon details. This decal was a little bit too large, and it also had that white or not white, but that clear outline that I was mentioning earlier with the vent decals. This had that too, and it made fitting it to the wing a nightmare. However, I did get it successfully on both sides, both thankfully to sheer accidents, getting things in the right spot, and decal softener. Something cool I'd like to talk about back here. Oh my god, my narration skills are off. Is the engines. The main engines are designed in such a way that allows you to gimbal them. I glued the bottom two in place, but this one actually moves, which is quite cool. It's not very useful, but it is cool. So I thought I'd mention that. How you thought I'd finally shut up about my challenges? No, there's still a bit more to go. So, since I was doing what every other high schooler in the United States does, and I was religiously studying space shuttle images while at school, I noticed that I missed way too many details than I would have been satisfied with. One of which being this section of black thermal protection system at the rear of the fuselage. And you'd probably think, how did you miss that? I'm clumsy, I do that kind of thing. So when I got home from school, I went to go paint it, and I masked off this entire area. That ended up resulting in the destruction of the NASA logo here on the wing, so I had an extra one laying around and I applied it on top. And you can kind of see the outline of the original NASA logo through the white letters of the one on top. You can barely see it, but it's there. It's a small issue, but it's kind of something that reminds me of, hey, don't be an idiot and miss details. Something also happened on the right side here since I missed it on both sides. The U on the United States title, I ended up destroying that, so I had to use the spare one that I had, and I put it on there, which it came out okay. You can barely tell that it's offline, but it's still issues that I experienced. The most recent and hopefully final modification I've had to make to this orbiter, at least external modification, I do want to do modifications to the payload bay, was this section of tiles on the silts pod. You see, since the silts pod was added, adequate thermal protection needed to be added to the vertical stabilizer as well. And they successfully did this by adding extra tiles. And this tile pattern is very specific. And originally I had the wrong tile pattern. It was too high up on the vertical stabilizer and it just wasn't the correct pattern. So recently I got tired of it and I decided to fix it, and now it's the correct pattern. I also had a lot of difficulty applying the matte clear coat. I had so many issues with that. Decals got destroyed, well, not destroyed, but damaged, that I was able to successfully repair, so I can't complain too much about that. But yeah, applying a clear coat for the first time wasn't really fun, but everything worked out in the end, so I'm very happy and grateful that I was able to do that. So for this segment of the video, I'd like to talk about why I chose to build the Space Shuttle Columbia and a bit of history behind this amazing space vehicle. The Space Shuttle Columbia was the first space shuttle to fly in space. As a result, it was used as a test bed. A lot of experimental instrumentation and features were fitted on it, and it retained quite a few of these features, but not all of them. Throughout its career, not only in those first few test flights, Columbia was very much an experimental vehicle. And it's this unique role that first caught my attention, and it gave me a bit of curiosity towards the vehicle. Another aspect of it being the external features, the chines and the addition of the silts pod with the extra thermal protection on the tail, those really stood out to me. It made Columbia very easily identifiable and differentiable from the other orbiters, which, aside from a few differences in their names, looked pretty alike to one another. However, Columbia retained a unique appearance through the entirety of its career. So those are some of the reasons why I chose to build Columbia, because, well, I liked its appearance, it was the first space shuttle, and it's just a cool orbiter. Why not? Columbia served a very unique purpose in the fleet as well. Since it was the experimental vehicle, it was very heavy, so it wasn't ideal for docking with space stations like the other orbiters. As a result, it was reserved for microgravity research and deploying heavy payloads. And Columbia also has a bit of history with payloads and iconic missions, because it was the shuttle that was flown by the first American female spaceflight commander, which was a major step in space flight for women, which was really cool. And ironically, on that same mission, I believe it was STS-93, it deployed the Chandra X-ray Observatory, the single heaviest payload deployed in space by a space shuttle. So Columbia has both of those titles, which is very nice. Now, the second reason, and the more primary motive as to why I built the Space Shuttle Columbia, was because its career was cut short far too early. As I mentioned, mission STS-107 was Columbia's final mission, and that's what this mission patch is here. This is a patch that the crew members of mission STS-107 wore on their flight suits. STS-107 was an iconic mission for various reasons. One, it had been delayed a ton of times, and it also was carrying the first Israeli astronaut in space. So Columbia definitely had a lot of first people in space, which was very cool. It was a microgravity research mission, and unfortunately, as I said earlier, it ended in disaster.
11, 10, 9, 8, 7. We have a go for main engine start. 5, 4, 3, 2, 1. We have booster ignition and liftoff of Space Shuttle Columbia with a multitude of national and international space research experiments.
On January 16, 2003, mission STS-107 began with the launch of the Space Shuttle Columbia. On board were 7 astronauts: Commander Rick Husband, pilot William McCool, mission specialist David Brown, mission specialist Kalpana Chawla, mission specialist Michael Anderson, mission specialist Laurel Clark, and payload specialist Ilan Ramon, the first Israeli astronaut in space. Their mission consisted of performing various microgravity research tasks and experiments while in orbit. After an almost 16-day mission, the shuttle was scheduled to re-enter the atmosphere and land at Kennedy Space Center. During launch, a large piece of insulation foam fell off of the external tank and struck the leading edge of the left wing, damaging the reinforced carbon-carbon thermal protection system. It was determined that, despite the hard hit, the damage caused was negligible and would not cause a problem during re-entry. On February 1st of 2003, the shuttle began the re-entry process. During re-entry, hot gases entered the breached thermal protection system, burning the internal structure of the left wing. As the orbiter passed over the southern United States, observers on the ground noticed pieces of the shuttle falling away. At 9 a.m. Eastern Time, Columbia lost control and suffered a catastrophic breakup, destroying the flagship of the shuttle fleet and taking the crew with her.
And Columbia, Houston, we see your tire pressure messages and we did not copy your last.
Roger.
The disaster resulted in the grounding of the space shuttle for 29 months. The disaster also marked the end for the shuttle program. After the loss of 2 orbiters and 14 crew, it was decided the shuttle would be retired after the completion of the International Space Station. The final shuttle flight, STS-135, took place in 2011. While the disaster itself was an international tragedy, it does not have an entirely tragic ending. Within half an hour of the fatal disintegration, hundreds of thousands of pieces of debris fell over East Texas and western Louisiana, spanning an area hundreds of miles across. Thankfully, nobody suffered injury from the falling debris, partially due to the debris falling over a mostly rural and lightly populated area. Now, the reason I say STS-107's end isn't really too much of a sad one is not because of the orbiter disintegrating and the 7 astronauts losing their lives. It's what happened after the disintegration and after the debris hit the ground. The people in the areas where the debris fell were very confused initially. All they heard was debris flying at Mach speed past supersonic, going subsonic, creating sonic booms, hitting the ground at force, creating a mixture of chaotic sounds and pieces of small mechanical parts to large machine parts falling from the sky with no explanation. However, this didn't stop people from immediately starting to search for the pieces to investigate what happened, and this later proved invaluable to the investigation since those pieces were recovered, logged, and shipped back to the Kennedy Space Center for further analysis. And when I say people who started searching, I mean everyone. Civilians, people like me, people like you, people like your family, people like EMTs, emergency service personnel, law enforcement personnel, anyone who could began searching for pieces, and pretty soon a large search effort was coordinated. Shortly after, people from NASA came, the Federal Bureau of Investigation came, and within days, people from all over the United States, and I'm willing to bet from all over the world, came to the disaster site, which spanned hundreds of square miles, and they began to work together to search for pieces of the shuttle. And in the end, the search effort recovered about 30 to 40% of the orbiter's weight, which was more than enough information and parts necessary to determine what really happened and caused the disaster. And it's this people coming together and completing a common goal. That's what really makes me proud to be human and to be born and raised in the United States, because the people of the world did that. And it really shows that even in times of crisis and sadness, when we come together as a whole, as people, it really shows that we are capable of some really impressive things. The recovery effort of Columbia is something that I describe as nothing short of a miracle. Unfortunately, we did lose 7 amazing people, and that's something that really is sad. But the loss of these 7 people brought hundreds of thousands together, and it resulted in something that ended up improving a lot of things for manned spaceflight. We haven't had a disaster since then. Safety restrictions on spaceflight have become a lot more strict, and so far things are going pretty well. The shuttle program, unfortunately, is gone, but that's led up to the opening of the private enterprise. SpaceX, not really Blue Origin because they're not really doing too well. Now NASA's trying to go back to the moon with Artemis program, and it still has its problems, but we're moving in the right direction. That's really what resulted from the Columbia disaster. So that's all I've really got to say. Thank you so much for watching and listening to this probably very long video, assuming after editing I don't cut out too much. And yeah, I'm glad you're here. I'm glad you listened to what I had to say. I hope you like the model. I certainly am very proud of it. And stay tuned for more spatial updates, because I do have a few more orbiters that I am building. Well, one that I built and a few others that I'm building. And stay tuned for those. So like, comment, and subscribe. Take care of yourself. Stay addicted to space. And I'll see you later.